to explain about what?
We're going to talk about what pressure is, what causes pressure, how temperature affects the motions of particles, what the
How pressure and temperature are related, how volume and temperature are related. It seems a lot, but it's not a lot. We're going to do an experiment, and we're going to explain you everything for that experiment.
Okay.
Get it?
Yeah.
But before going to the experiment, I want to just give you some pre-assessment tests.
Don't worry, it's not going to be
It's not going to be graded, just for you to know
now.
what. Yeah.
Let's do it, Daniel.
If you don't know, just live it. Okay? If you know it, you do it. When you, I got 5 minutes for you, and then we're gonna start our lesson.
What is today's date? June 3rd. We should know this, but I just forgot all.
If you don't know, just live it. Do it.
Pressure. Pressure. Is when something pushes on something. Pressure is peer pressure. Yeah.
Alrighty.
Something
So
pushing
before
on
we get
something.
started, my guys, ladies up front. We're gonna get started at the same time. Make sure your recorders are on. And the guys that Miss Fresca has, the rubrics that you have, make sure you do them at the end of the presentation. Alright, so you go through the presentation and the assessment, do them at the end.
This is at the end.
Okay? Not right now.
Something pushing.
Alright, so go ahead and get started. Make sure the recorders are on.
Do it later. Sup, homie? You did great.
If you don't know, just live it.
He has cubes. Cubes and the same thing.
What are their names?
Can we get some of your indicator cubes?
Well, in chemistry, there's control how big
That'd be it.
I got what pressure.
It's okay, don't worry.
Yes. I'm not confused. There's a straw in there.
People put a lot of garbage in those chemicals.
That's smart. Put a straw in an electric bottle.
1 minute.
Boils. Go. Smooth.
So before, this is stuff that you're gonna
Yeah,
do.
I should put your names down.
And before going to the experiment, I'm gonna explain something. So first thing, do you know what the three states of matter are? What are? When you have solid, how do the particles look like? How do the particles look like? The molecules. That's good. When they are liquid, so what we're going to do is they are like this. They are a little bit separated. When they are gas,
Very spread out.
so when we see at gas particles, these are the particles, these are the atoms. So the arrows, this represents the speed of the particles. See? So if the arrow is longer, more speed, shorter, less speed. So this, more speed or less speed? This? Get it. You know, do you know what temperature is? What is it? How hot or how cold is something, right? And what is volume?
Something that takes it's like blank times height.
Volume of space.
I was trying to say that. I was like, the amount of space something takes up.
Yeah, the amount of space that an object takes. The amount of space that an object takes. So we're going to start our experiment.
Giggles. Go,
Try this one. Is better? So now you need to pay close attention, alright? We're gonna have from this product we're gonna have. Which color is this? And I'm going to explain how you get that. So now what's happening is we have a can, right? Then we have small amount of water, right? And then we have gas particles. Here. So here we have fire, right? This is fire. So when we add fire, what are we adding? Right? Fire equals to more temperature, right? So when there is more temperature, how do the particles move? Slower or faster? Faster, right? That's you. Daniel, what's the arrow for faster? Bigger or smaller?
bigger.
Right? So they're moving fast, very fast. So at the pre-assessment at the beginning, here I asked you what pressure was. And you told me the force is a force. That's right, it's a force. But what exact pressure is the collision between this particle and the container. When this particle hits the container, it creates pressure. That causes pressure. What causes pressure?
The particles.
Heat the
Yeah, the heat.
the container,
Yeah.
the can. So pressure the particle heating the container. Get that? You have any question to this point?
So guys, do you know what a pH is?
That's what's happening. So they're moving fast. But pay close attention. You may be confused between particles hitting each other and particles hitting the container. This does not cause any pressure. Particles hit each other, they don't cause any pressure. What makes them cause pressure is when they hit that container. That's when pressure is caused. So, what's pressure? And how, when we increase temperature, what do we increase? No, you. So when there's more temperature, they move? How they move? When there's low temperature, they move? So that's what's exactly happening. So is there more pressure or less pressure here? When they started to move faster, more pressure because they were first moving like this. Suppose this is the particle and this is the container. So they were first moving like this. Then when you add temperature, they start to move like this. So this causes the pressure when they hit the container, right? So when temperature increases, when T stands for temperature, goes up, pressure goes up, right? Because when we increase temperature, we increase the speed, and the increase of speed made the gas particles to hit the container more often, and this collisions created what? What this create? What does this create when the particle hit the container? Pressure. Pressure. So that's what happened. So I told you at the beginning that you're gonna have at the end this product, right? Did we have it? So now you might ask, what happened? So this was the beginning, right? Now let's look at it. First of all, comparing this to the beginning, this was the beginning, this is the end. This is the end. This is what we have. This is the beginning. Comparing to the beginning, do we have more volume at the end or less volume? So we have less volume. V stands for value. So what did happen here? What happened here is that when we put this from fire to cold water, cold water, how do the particles move when there's less temperature? Slower. So there should be smaller arrows, right? So is there more pressure or less pressure? Why? Because they're moving slower. So this is how they move. Slower. When they start to move slower, they created a vacuum. You know what a vacuum is? It's a free space. Like when they were moving fast, they were filling in main space. But when it started to move slowly, they left a free space. And this free space called vacuum. This free space called vacuum causes the can to collapse. So when they started to move slowly, first of all, when we put this in the cold water, did the temperature increase or decrease? Then what? How do the particles start to move? And then, did the pressure increase or decrease? So do you have any questions to this point? You get all of that? That's good. So here, the tank collapsed.
What makes something?
So this is what the end, right? So I told you volume, there's less volume compared to the beginning, right? So, when there was more temperature, do we have more volume? And Daniel, when we have less temperature, what do we have? Less volume. Why do we have less volume? Collapse? Yeah, why did the plane collapse? Where was that? Free space. Because there was a free space, the can collapsed and the volume went down, decreased, right? Do you have any questions at this point? So yeah, this is basically what happened in the experiment. This is what was the experiment. So this is called direct proportional. Why? Do you know why it's called direct proportional? Because when temperature, when one increases, the other increases. When one decreases, the other one decreases. So, when A increases, B do what? When A increases, B, what does B do? Again, that's what exactly happened. So this is called what? Or direct relationship. You can call it a direct relationship. So I want you to scan the board and fill in this temperature and time. Good. When temperature increases, what happens to the water? When temperature increases, what is this called? And what happens to the pressure? When temperature increases, I'm going to ask this question to you. What does pressure do when the temperature increases? So, those two are called direct. Temperature and pressure are direct. Temperature and volume. So, this is called Charles' law. And you knew it at the beginning. Good job. This is called, guess what? Boyle's law is that exists in important law, but we're not going to discuss Boyle's law today. So what is this? No. Gay Lussac. So what does Charles' law says? You. So, and what does Gay-Lussac's law say? That's right. So, do you have any questions at this point? I'm quite excited. So I want to ask you some questions. You just see if you understand everything. Well, wait. Before going to that, I want to tell you something. The particles outside the plant, they remain the same. let's say there are 3 gas particles outside the can. They have the same speed. And they move normally. Nothing happens outside. Same thing here. When you have fire, right? With temperature did what? And pressure did what? So the particle started to move. Okay. So, but the thing you have to notice is the particles outside, they were just moving normally. Nothing changed outside. Look, nothing changes outside. Get that? Now, we're gonna ask you some questions, just to make sure that you get everything right. Don't worry, I'm not gonna grade you on these questions, but I want to just ask you some questions.
Alright. Can you tell me what caused the pressure in the can? Either one of you. The next one down.
When the heat increases,
Yeah.
the pressure went up in the door.
Yeah, but what causes the pressure inside the can? How is pressure caused? Yeah. When they hit the container, right? Right, Daniel?
Yes.
You get it.
Okay. Who's next?
Daniel's next.
Okay, Dan.
Yeah.
What is temperature?
Temperature is pretty much
That's the right answer. How hot or cold is and
an object.
what is
guys know
value?
this
How much space is it?
Very good. What is a vacuum?
A vacuum is like a thing that
Not the object.
Not the cleaning vacuum.
Vacuum, what is a vacuum? Start with an F.
free space.
What is a vacuum? Okay.
Very good.
So, ask me a question.
How do molecules move when there is more temperature?
Maybe.
Yeah.
They move faster.
Very good. How do molecules move when you take temperature? Very good.
What's Charlie Lowe said?
No.
Charlie
Didn't
Lowe
say
said.
anything. How'd you get it wrong?
What Charlie Lowe said?
Temperature. When temperature increases, increases too. The volume increases.
Very smart. And when it decreases temperature?
The volume increases.
And what is the other law? And what it says?
The temperature increases, the pressure increases, and when the temperature decreases, the pressure decreases.
Very nice.
What does it mean to have a direct relationship?
Or direct proportional.
Proportional. It means to like have whenever something goes up, it goes up. It goes up. It decreases. It decreases.
Alright.
So what happens to the particles outside the can?
They just stay.
What happens to the particles outside the can? What causes the can to collapse? What causes the can to collapse?
When the particles move faster than the heat, or no, the heat causes particles to move faster to collide with the
Yeah.
to collapse.
What?
To collapse it.
What collapsing?
To like record